Now that we've learned what fundamental identities are, let's see if we can simplify some trigonometric expressions using these fundamental identities. Oh yeah, trigonometric expressions. Yeah, totally what I meant. So we have the four different kinds of identities. We have the quotient identity, the reciprocal identities, the Pythagorean identities, and the cofunction identities. So let's talk about how to actually use them. Number one thing to look for when given a trigonometric expression is pose the question, are all angles equal? It's going to be important that in order to use three of those types of identities, all of the angles have to be equal to each other. If not, check to see if the angles are complementary. So check for complementary angles. And by that I mean check to make sure that the angles add up to 90 degrees or pi over 2 radians. Now, if there are some complementary angles that are in here, you can use the cofunction identities to get everything in terms of the same angle. So use cofunction identities to get the same angle. Now, once you do that, check to see if there are squares of trigonometric functions. So if squares are present, then consider a Pythagorean identity. Now, the only time that Pythagorean identities work is when you have squares of trig functions. So if you don't see them, go ahead and move on to the next step. So another strategy is going to be express everything in terms of just the sine and the cosine. Sine and the cosine, which is always possible using the reciprocal and quotient identities. Now, once you do that, you'll be making use of algebra to attempt to simplify everything else. So with that in mind, let's take a look at some actual examples of simplifying trigonometric expressions. We will start with the secant squared of 28 degrees minus the tangent squared of 28 degrees. So first thing to point out is that all of the angles are the same, so we don't need to worry about cofunction identities. We also see that there are squares of trig functions here. So I will ask you to recall with me, there is a Pythagorean identity that involves the secant as well as the tangent, and it is that 1 plus the tangent squared of any angle is equal to the secant squared of that angle. Now, if you perform a little algebraic manipulation on this, this also lets you know that if you were to have the secant squared of an angle minus the tangent squared of that angle, what's left on the left-hand side? That would be 1. That would be considered the way to simplify this expression. So we are able to simplify this using only one step, and that is through the use of our Pythagorean identity, or one of our three Pythagorean identities, I suppose. Next example, cosine of 40 degrees divided by the sine of 50 degrees. So first thing we check to see is, are all of the angles the same? If they are not, check to see if the angles are complementary. So we'll say over here, note, 40 degrees is not the same as 50 degrees, but it does check out that the two angles are complementary, because if I add them together, I get 90 degrees. Now, what this means is, if I apply a cofunction identity to the cosine of 40 degrees, I can turn it into the cosine's cofunction. As a reminder, a cofunction, if the function doesn't already have a co, give it a co, and if it does have a co, take the co away. So the cofunction of cosine would be sine. If I were to apply it to the sine, I could turn the sine into a cosine and the 50-degree angle into a 40-degree angle. It doesn't matter which one you do, so there are honestly two different options that you can do for this one. I can apply a cofunction identity to the top turn the cosine into a sine, and turn the angle into 90 degrees minus 40 degrees. The denominator would stay the same. Now with that in mind, I could also apply a cofunction identity to the bottom. And if I apply a cofunction identity to the bottom, sine becomes cosine, and 50 degrees becomes 90 degrees minus 50 degrees. In the first case, this winds up being equal to the sine of 50 degrees divided by the sine of 50 degrees. In the second case, this would wind up becoming the cosine of 40 degrees divided by the cosine of 40 degrees. And I guess it didn't really matter which one of those I did, because we're going to wind up with the same thing either way, and that same thing is going to be 1. So, example of the cofunction identity combined with a little bit of algebra. Let's go ahead and try out a couple more. Next one that we see right up top on this page is 1 plus the tangent squared of 5 degrees minus the cosecant squared of 85 degrees. Now, first thing we check for is, are the angles equal? They are not equal to each other, but thankfully, if you add these two angles together, we do see that they wind up being complementary because they have a sum of 90 degrees. Now this means I can either turn the 5 degrees into 85 degrees, or I can turn the 85 degrees into 5 degrees by applying a cofunction identity. I'm going to turn the 85 degree angle into a 5 degree angle. Because it's cosecant, the co-function of that would take away the co, and it would become the secant of 90 degrees minus 85 degrees. Leaving us with 1 plus the tangent squared of 5 degrees minus the secant squared of 5 degrees. Now, I do see that we have a couple of squares here, so something to check would be, does a Pythagorean identity work in this case? Here's the Pythagorean identity that involves the tangent and the secant once again. If I were to perform an algebraic you know what? I'm not even going to bother performing an algebraic manipulation. I'm just going to turn this 1 plus tangent squared of 5 degrees into the secant squared of 5 degrees, which is what the Pythagorean identity says we can turn it into. We're left with the secant squared of 5 degrees minus the secant squared of 5 degrees for a final answer of 0. And finally, cotangent of 25 degrees times the cosecant of 65 degrees times the sine of 25 degrees. We are dealing with two different angles on this one, so we'll check to see, are they complementary? If they're complementary, we can use some cofunction identities. Add them together, we get 90 degrees, so we are good to go. So your options are, you can turn the two 25s into 65s, or you can turn the 165 into a 25 by using a cofunction identity. I'm going to go with the latter because doing one thing sounds a lot better than doing two things. The cofunction of the cosecant would be the secant. Just take the co away. And this would be 90 degrees minus 65 degrees. And then sine of 25 degrees. So simplifying that angle, we will get the cotangent of 25 degrees times the secant of 25 degrees times the sine of 25 degrees. Now everything is in terms of the same angle. Next thing I want to do is check to see if there are any squares present. There are no squares present, which means that we can proceed to express everything in terms of the sine and the cosine. So the identities that I'll be using, this one is called a quotient identity, where the cotangent is equal to the cosine of an angle divided by the sine of an angle. Additionally, for the secant of this angle, the identity is that it is the reciprocal of the cosine. That is, again, using a reciprocal identity. So cotangent, I'm going to express as the cosine of 25 degrees divided by the sine of 25 degrees. Got to copy the angle in both the numerator and the denominator. Times secant, we just said, by the reciprocal identity, is 1 over the cosine of 25 degrees. And because it feels left out, I'm going to express the sine of 25 degrees as a fraction as well. All of these fractions are being multiplied together, which means that I can go straight across the top and straight across the bottom, or point out that if you have a factor in the numerator and a factor in the denominator, you can get them to cancel out. So the sine of 25 degrees cancels with the sine of 25 degrees. Cosine of 25 degrees cancels with the cosine of 25 degrees, leaving me with nothing but 1s. So final answer for this one is going to be 1. Now, don't stress these problems too much, because if you take a look in the textbook, every single answer for one of these problems is either 1 or 0, and as a reminder, my math lab gives you 3 attempts per problem.